Hey guys, welcome to my channel, and this lesson is about graphing quadratic functions in standard form from my axis of symmetry and my vertex. The first function we're going to be working with is f of x. Remember, f of x is just a fancy word for saying y is equal to x squared. Well, in order to find my axis of symmetry and my vertex, I first need to know my a value, my b value, and my c value. So ax squared, I have my x squared. I don't have a number in front of this x, therefore it's understood to be 1. No bx, well, if I don't have a bx, what number stands for I don't have one? 0. And I don't have a c, so a value that stands for something that I don't have is 0. Now, in order to find my axis of symmetry algebraically, I need to use this formula. My x value for my axis of symmetry, that little vertical line that's going to cut my parabola in half, is equal to negative b all over 2 times a. Well, let's substitute. I have x equals to negative b, which is 0 in this case, all over 2 times a. In this case, a is 1. And I need to simplify. So x is equal to 0 all over 2, and x is equal to 0. So my axis of symmetry, that vertical line is going to cut my parabola in half, is x is equal to 0. Now, to find my vertex, they said it's hk. hk, guys, is nothing but my x and my y values. So I need my function that I began with. We're going to use function notation to find out what my f of x, aka y value, is for my vertex. So I take my axis of symmetry, which is my x value, that said was 0, and everywhere that I see an x in my function, I'm going to substitute it with a 0. So when x equals 0, f of x is also equal to 0. So in this case, x equals 0 and y also equals 0. So now I take my x and my y value and I plug it in for my vertex. My x value is going to be 0. This is where my axis of symmetry comes from. And my y value that I just found was also 0. So now I have my vertex. Now I'm going to take my vertex and I'm going to make me a table of x values and a table of y values. 5 is good enough for a quadratic function. So I take my vertex and I put it in the middle of my table. Remember, my x values is just like a number line. So I'm going to go down 2 values. And on the other side, I'm going to go up 2 values. In order to find my y values, I simply substitute the values into my function. So I substitute my x values in for my function to get my y values. So I have negative 2 squared is positive 4. Negative 1 squared is a positive 1. I have 0, 0 from my vertex. And I have 1 squared is a positive 1. And I have 2 squared is a positive 4. What do we notice about these values on this table? From my vertex, my y values are symmetric on both sides. They're the same. It will always be the case. All right, now let's plot these points. All right, my first point is negative 2 and 4. So that's negative 2 for x and a positive 4 for y. Negative 1 for x and a positive 1 for y. My vertex, which is 0 for x and 0 for y. I have 1 for x and a positive 1 for y. And I have 2 for x and a positive 4 for y. Now let's connect these dots so we can see the shape of our parabola. This parabola is facing upwards. It's facing upwards and it's opening up because to me it looks like a smiley face. Therefore, I can say that it is opening up. This is also my parent function. It's the most basic of the quadratic functions that it can look. Now let's talk about our domain. We know that our domain is our x values. So that means I'm looking from left to right. I want to know how far left and how far right do my x values go. Well, I have some arrows up here. So these arrows tell me that it's going in the left direction forever and ever and ever and ever, and it's going in the right direction forever and ever and ever and ever. So I can call those all real numbers. For my range, those are my y values. So for my range, I'm looking for how far down to how far up do my values go. Well, it looks like my range starts right here. This is where it starts, at this little point. Well, are my y values going below this point? No, they're all going above it. Therefore, my y values will be greater than or equal to this point right here. All right, so let's talk about my vertex on this graph. My vertex and my axis of symmetry. Where's the middle of this graph? If you say it right in here, you're absolutely right. What point on my x-axis does this vertical line split the parabola in half? At 0. And we said that was that from my axis of symmetry. We know that my axis of symmetry splits my graph in half at 1 point and 1 point only. This point right here, which is my vertex. My vertex is an x and y value. And it's right here at 0 for x and 0 for y. All right, let's talk about maximum and minimums. Is this a maximum or a minimum of a graph? Minimum means the lowest point, and this is the lowest point of the graph. Therefore, it is a minimum. And last but not least, let's talk about our roots and our zeros, aka our x-intercepts and our solutions. X-intercepts, my roots, my zeros, my solution, they only cross my graph on the x-axis. And where does this cross the graph on the x-axis? At 0, so I will only have one solution. Let's try another graph. All right. In this quadratic function, we have f of x is equal to x squared plus 6x plus 8. Let's figure out what our a, b, and c values are. For my x squared, I don't have a number in front of it, therefore it's 1, a positive 1. My b is a positive 6, and my c is a positive 8. Well, we can tell a couple of things from our graph from our a value. When a is a positive number, my graph will always open up. Meaning it will have an upward shape. And it will be a minimum. Because it's the lowest point on the graph. All right, now we have our A, B, and C values. We have determined that because A was positive, my graph, whenever I do graph it, it will be an upwards facing graph and it will be a minimum. All right, to find my axis of symmetry, I use the formula x is equal to negative b all over 2a. So let's just substitute those points in. Negative b all over 2 times a, which is 1. Now we just need to simplify. And I have x is equal to negative 6 over 2, and my axis of symmetry should be a negative 3. I now take my axis of symmetry, x value, and I substitute it in my function for x. I'm going to use function notation, and wherever I see an x, I'm going to substitute it for a negative 3. And now I'm just going to simplify. Negative 3 squared is a positive 9. A positive 6 times a negative 3 is a negative 18 plus 8. Just going to do a little order of operations. 9 minus 18 is a negative 9 plus 8. And negative 9 plus 8 is a negative 1. So that means my x value is negative 3 and my y value is a negative 1. Now I just plug these in to my vertex. Remember, HK is the same as XY. So my x value is negative 3 and my y value is a negative 1. Now I have my vertex. So now I take my vertex and I make me a table to graph, and I put my vertex in the middle of my graph. So negative 3 for x and a negative 1 for y. My x values, remember I'm just making a number line for my x values. I'm going to go down 2 values and then I'm going to go up 2. Make me a nice little number line. To find my y values, I need to substitute my x values into my function. Well, when I substitute negative 5 into my function, I get 3. When I substitute a negative 4 into this function, I get 0. Now you can also substitute these two values of negative 2 into your function, but I already know that from my vertex, on both sides of my vertex is symmetric. So you can easily just put, since it's 0 here, symmetric would be 0 here. 3 here, symmetric will be 3 here. Now I need to graph these points. This is my x-axis and this is my y-axis. So I have negative 5 and 3. So negative 5 for x and a positive 3 for y. A negative 4 for x and a 0 for y. A negative 3 for x and a negative 1 for y. A negative 2 for x and a 0 for y. And then a negative 1 for x and a positive 3 for y. Let's connect the dots. And I have a nice symmetric parabola. Now we said when our A was positive that my parabola was going to open up and I would have a minimum. And yes, I do. We said our axis of symmetry was negative 3. Well, let's see if we're right. This is the middle of my graph, so if I wanted to draw an axis of symmetry, it would be right there. What point is that on the x-axis? Absolutely right, a negative 3. We also said our vertex would have been a negative 3, 1. Well, this is the point where that axis of symmetry crosses the graph just once. And it is at negative 3 for x and a negative 1 for y. Let's talk about our domain. Like we said, the domain is my x values, and I'm looking how far left and how far right do my values go. And on the left, I have an arrow, which means it's going forever and ever in the left direction. And on the right, I have an arrow, which means it's going forever and ever in the right direction. Therefore, it's all real numbers. All right, my range, I know it's looking at how far down and how far up do my values go for my y. Well, this is how low it is. Are my x values above this? Are my y values above this or below this line? They're above it. Therefore, my y values for my range will be greater than or equal to whatever number this is on my y-axis, which is a -1. All right, I know my roots and my zeros cross the graph at the x-axis. So this is my x-axis, and it crosses it here and here. What are those solutions? So it crosses the x-axis at -4, 0. And it crosses the x-axis at -2, 0. Or you might see it just as x is equal to -4 and -2. All right, let's do one more graph. So we have f of x is equal to a -x squared plus 4. Let's identify our a, b, and c values. Well, in front of this x, I have a negative sign. I don't have a number, but we know that it should be 1 if I don't have one. But this negative makes it a -1. My b value, well, I don't have a bx. So if I don't have a bx, what number do we use for something that we do not have? 0. And my c value is 4. Alrighty, so now when my a value is negative, I can tell some things about my graph. So when a is negative, my graph will open down. And open down meaning it will be facing down like this, like a frown. And it will be a maximum because this is the highest point the graph will be. All right, my axis of symmetry, I need to find that vertical line that's gonna cut my parabola in half, and I have x is equal to -b over 2a. So I have my negative times whatever my b value is, which is 0, all over 2 times a, in this case, a -1. Well, anything times 0 is 0, and 2 times -1 is -2. 0 divided by -2 is 0. So my axis of symmetry is x is equal to 0. All right, now I take this axis of symmetry and I substitute it into my function in order to find my vertex. Don't be confused with the h and k, guys. Remember, it's just x and y. So we're gonna use a little function notation. And wherever we see an x, we're gonna substitute a 0. And let's just simplify. 0 squared is still 0. Anything times 0 is 0. So when x is 0, my f of x or my y is equal to 4. So my vertex is my x value from my axis of symmetry and my y value from substituting my axis of symmetry into my function. Now I have my vertex. Now let's take this vertex and put it in the middle of my table of values so I can graph. Again, for my x values, I'm gonna make a number line. So I'm gonna go from 0, I'm gonna go down 2. And then from 0, I'm going to go up 2. Now, in order to find my y values, I need to substitute my x values back into my function. When I substitute -2 into my function, I get 0. And when I substitute -1 into my function, I get 3. Now I can substitute my 1 into my function, but I know from my vertex, it's symmetric on both sides. So this would be 3 and this would be 0. Now let's take these points and make our parabola. I have -2 for x and 0 for y. I have -1 for x and a +3 for y. I have 0 for x and a +4 for y. I have 1 for x and a +3 for y. And I have 2 for x and a 0 for y. Let's connect our dots. All right, so we said when my a value was negative that my graph will open down. It will be a downward shape. I know it's opening down because it looks like a frown. And this is the highest point, therefore it's a maximum. So we were right. Let's find the middle of this parabola. Well, the middle looks about right here. This little vertical line is gonna cut that parabola in half. So this vertical line that's cutting my parabola in half is my axis of symmetry, which is x equals 0. So we also said that this was a maximum, meaning that it's the highest point on the graph. This highest point on the graph is my vertex. Well, what point is this vertex for x and y? X is 0 and y is 4. Look at that. Same. All right. Let's talk about our domain. We know our domain is our x values, meaning how far left and how far right does my graph go. Even though it's going downwards, my x values are still going in the left direction forever because it's an arrow here. And they're also going in the right direction forever. So it's still all real numbers. Hint, hint, guys, my domain for a quadratic function will always and forever be all real numbers. All right, my range, which is my y values, meaning how far down and how far up does my graph go? Well, it looks like it's kind of chilling right here. So are my y values above this dotted line or below? Correct, they're below it. So that means my y values, because all of them are falling below that line, will be less than or equal to whatever this y value is, which is a 4. All right, let's talk about our roots and zeros, x-intercepts, our solutions. How many times does this parabola cross my x-axis? Once here and once here. Well, what values are those? -2, 0, meaning -2 for x and 0 for y, and +2, 0, +2 for x and 0 for y, or x is equal to -2 and 2. Thanks for tuning in, guys.